Now let's move on to the sessions. In sessions, you can define a new query. You simply click on New Session and create one. I've already done that. In the first section, you enter your question. For example, my question was, explain the tolls in Germany based on emission class and axle types. This type of question is very useful for companies, especially those operating across borders, because it helps them understand differences in tolls and plan accordingly. As you can see, the platform has generated a concrete answer for me. But you might be thinking, this is great, but where does this information come from? And this is where MStar stands apart from other applications. Not only does it provide the answer, but it also shows how the answer was generated. Essentially, it gives you the explanations and the source data behind the response. This transparency is key for trust and actionable insights. First, let's take a look at our query graph. Here, the query has been decomposed into its base entities, and this graph shows all the information MStar considers necessary to answer the question. One of the most important features of this graph is that it tells you how well the system understood your question. This is a key difference from traditional LLMs, which are essentially black boxes. With standard LLM applications, you often have no visibility into what the model actually understood, or whether it's searched for all the relevant elements of your query. With MStar, you can see the decomposition, the entities involved, and how the system is reasoning, giving you transparency and confidence in the answers it provides. Next, we move to the answer search graph. This is essentially a smaller version of the concept type graph. By smaller, we mean it only includes the information relevant to your query, which narrows the search space and makes the process more efficient. Under the hood, this graph maps the relations and connections from the source data to the concept types extracted from your documents. As you can see, this query had 3 relations. Each color, blue, green, and orange, corresponds to one of those relations in the query decomposition. The black nodes, labeled as answer nodes, represent the information that may be necessary to generate the final answer. It's important to note that this is just the search space. MStar performs an iterative process under the hood, traversing these links to find the actual answer. This iterative process can seem a bit complex at first, but we'll explore it in more detail in the final section. In this case, there are 36 results. This means that MStar evaluated 36 different paths within the search space to find the answer. You can see each path represented as a tag on top of each iteration. The score associated with each path indicates how relevant that path is to your query. As you can see, the first few paths weren't very strong, so MStar continues iterating until it finds the top answer. In this example, the top answer achieved a score of 9, representing the most relevant and reliable result for the question we asked. If you look at the top path, you can see that it makes sense. It's considering the tools, cost metrics, vehicle attributes, and Excel information on emission class. This shows that the path is looking at all the relevant elements to generate a real, reliable answer. And that's essentially the final answer generated by MStar. The answer summary is essentially MStar's memory of previous answers. As the system evaluates each path, it doesn't just consider that single path in isolation. It also extracts partial answers from each path and keeps them in memory. The answer summary is this collection of memories. When generating the final answer for a query, MStar pulls from these stored partial answers, even if they came from different paths or different parts of the document. This approach not only improves the accuracy of the final answer, but it also allows you to track how partial insights from various paths are combined to produce a coherent, complete response. In this section, you can also see the tables extracted from the document. Even though we started with a PDF file, MStar automatically identifies and extracts tables, treating them as structured data. The reason for this is simple. We don't want to expose any sensitive information from the unstructured content. That's why in the concept type graph, there are no raw data values, concepts only. If you're looking for a specific number or value, you can use filters to find it, and MStar will show you exactly which table and which part of the document the value came from. Importantly, these tables are not generated. They are the raw data directly from source. This means you can always backtrack any extracted value to its original source, ensuring full transparency and traceability. Finally, in the last part, we have the meta context files. These files represent the raw chunks of the data that MStar uses to extract information. You can think of them as the building blocks behind the concepts and tables you've seen. For example, this is one of the tables, and the corresponding meta context shows the underlying chunks that were processed to generate it. And that covers how MStar handles unstructured data. Now let's move on to next step on how to process structured data stored in DB. Starting with defining project name and database domain. This is the semantic or industry domain, such as financial or healthcare. This time we select Database URL mode, and we'll pass a connection URL to our database. Just making sure database instance is reachable over the internet or privately accessed via tunnel. After defining the project, let's run the project. After successful run, project card will turn green, and just make sure you have selected that project as active project on top. Next, let's take a look at the concept type. In the case of structured data, the concept type essentially represents the schema. As you can see, MStar has automatically extracted all of this information, including the columns, which it will use to answer your queries. With that in place, let's move on and explore the sessions. I've already created a few sessions, so let's start with an example. For instance, this question: how many accounts with a region in Prague are eligible for loans? To answer this, the system needs to know exactly which tables store this information. This can be extremely challenging for a standard LLM, especially with structured data. Tables may look similar, there may be many of them, and multiple relations need to be considered. Traditional agent-based solutions require a lot of manual exploration. MStar finds the right tables, identifies the correct links, and navigates the schema to answer the query efficiently. As you can see, this sample question has generated a fully evaluated answer. MStar not only produced the SQL query, but also returned the verified result. I double-checked it, and the answer is correct. Now let's take a look under the hood at how this answer was generated. First, we examine the query graph. Here, you can see that MStar has extracted every element of the question. For example, it captured the region, Prague, and the concept of a loan. This shows that the system fully understood the query, providing transparency that traditional LLMs as black boxes cannot offer. Next, let's examine the search process. Specifically, which parts of the schema were necessary to generate this answer. MStar is able to navigate through all possible paths in the concept type graph to find the correct answer efficiently. In this view, the black nodes represent the final tables used to produce the answer, while the colored nodes correspond to specific relations in the query. This visualization makes it clear how MStar connects the right data elements to fully satisfy the question. This is the first step in generating answer query. Now let's take a look at the iterated results. To generate this answer, MStar evaluated 7 different paths. Interestingly, you can see that another path produced a slightly different answer. This highlights the power of MStar. You're not only seeing the final answer, but you can also trace back and understand how it was generated. For example, in this alternative path, the system generated another query and produced a different result. This indicates that there might be conflicting data within the database, something we wouldn't have known without this level of transparency. In this case, because we're using example or synthetic data, it's likely a data inconsistency. But the system allows you to identify and investigate it directly by running the query and checking the source. The answer summary is essentially memory of previous iterations. As MStar evaluates each path, it may generate partial answers for the query. These partial answers are stored in memory to help improve the final response over time. In other words, the answer summary collects and integrates these partial insights until the system produces a complete and accurate answer. This step is particularly interesting because it shows the reasoning of the agent. MSTAR uses an agent-like approach to communicate with the database. Once MSTAR identifies the initial query, the relevant paths, and the necessary schema information from the concept type graph, it passes this to the agent, which handles the rest of the process. Here, you can observe the evolution of the answer. Along the way, there were several errors, but the system iteratively corrected them. In the end, MSTAR generated the final query and produced the accurate answer for us. Thank you so much for coming with us this far. If you have further questions or want to collaborate with Omid, you can find him on LinkedIn. Angry Graph Lab is looking for collaboration and early adopters, so feel free to reach out. Have an amazing day.